Water is an important part of life. It's all around us, in us, it's part of everything we do. So shouldn't preserving its quality be important too? One strategy engineers have developed to combat the decline of water quality is green roofing. Green roofing is a layer of soil and plant life on the top of a house or building. Green roofs can range from a covering of low-maintenance sedum to extensive rooftop gardens. Whatever the style, the primary way that they help regulate water quality is by absorbing excess rainfall.
Mainly in urban areas, once shed off of a rooftop, rainfall hits pavement, mixing with oil and other chemicals, and is carried along gutters to storm drains and eventually water treatment plants. For light to moderate storms, this is not an issue. For heavy storms, however, problems can arise when the load becomes too much for sewage systems to contain, and the untreated water overflows into streets, houses, and nearby waterways. Rooftop runoff can also contribute to bank erosion into waterways, further reducing water quality. With green roofing systems in place, soil and plants soak up a high percentage of the rainfall, utilizing some of the water for plant growth and releasing some of it through the process of evapotranspiration back into the atmosphere. We talked to Professor Elizabeth Grant, who was in charge of one of the green roof projects here at Virginia Tech, and she explained a little bit about how green roofs work.
Okay, essentially they work by evapotranspiration. That's the main mechanism. So essentially you have a vegetated surface, and what happens is the sun shines on it, and the sun converts liquid water from rainfall into water vapor.
As beneficial as green roofs are, however, they do come with their own set of challenges. The water and weight associated with green roofs have to be addressed before installation to prevent structural failure of buildings on which they are placed. Waterproof membranes have to be installed to prevent leaking, and structural modifications may need to be made to buildings.
It's about 6.75 pounds per inch of depth of green roof of additional load. So, if you have 4-inch deep green roof, that's about 28 pounds per square foot of additional load. So in that range, you start to have to make some adjustments. Often you'll have to weld an additional angle to the underside of the deck to kind of stiffen the whole thing.
Taking the pros and cons into consideration leads one to wonder whether or not green roofing has a bright future in this area. Tess Thompson weighs in on the matter.
Are green roofs the solution? Depends on what the problem is specifically. Green roofs they're not a cure-all. They're most effective where you have small, low-intensity rain events. They're very common in Germany. They're used a lot there. That's not Virginia.
Not Blacksburg, right?
That's not Blacksburg. That's not to say they don't have benefits.
So green roofing may not be the end of the line when it comes to permanently solving water quality problems, but they remain worthwhile considerations in urban environments where reducing storm water runoff is needed.